The Kruskal Wallis test is a non-parametric alternative to analysis of variance that can be used when some of our conditions are not met. Remember that the conditions that we have in order to be able to use ANOVA to compare means between multiple groups, we need to have independence between observations, we need to have independence between groups, we need to have nearly normal distribution in each group, although that can be relaxed for large sample sizes, and we need to have equal variances in all of the groups. Now, we can't get around the independence conditions using the Kruskal Wallis test, but we can if the normality and or equal variances or conditions are not met, use the Kruskal Wallis test as a non-parametric alternative to ANOVA. When conducting a Kruskal Wallis test, the null hypothesis is that the median is equal in all of the groups. The alternative is that not all group medians are equal, so these are very similar to the ANOVA hypotheses, except that they are about medians instead of about means. The example that we're going to use is related to advertising. It's expensive to pay royalties to use a Beatles song in commercials. To find out whether it is worthwhile to do so, an advertising company created 3 versions of a commercial. A random sample of people were each randomly assigned to watch one of the commercials and rate how appealing it was on a 100-point scale. The first commercial had the Beatles' Revolution as the soundtrack, and those are the appeal scores. The second one used a randomly selected pop song as the soundtrack for the commercial. And the third version used no music in the background of the commercial. How does the Kruskal Wallis test work? Well, we start by combining the data from all of the groups and ranking the values from smallest to largest. So this is very similar to how we started with the Mann-Whitney test. Then we sum the ranks for each group and define R sub I to be the sum of the ranks in the ith group. We also define N sub I to be the sample size for the ith group and N to be the total sample size of all groups combined. Then we calculate this H test statistic, and we can use the chi-square distribution with the degrees of freedom equal to the number of groups minus 1 if the sample sizes are at least 5 in each cell, or we can use a table, and there are many different versions of this table depending on which book you look at, to find the p-value if we've got smaller sample sizes than that. And once we have the p-value, we will make an appropriate conclusion. So again, the data for our example are shown here. We're going to start by combining them into one big set of data and ranking them from smallest to largest. So here we've done that. The data are combined. Still can identify in that last column, which commercial the data values were associated with. The data values are in the left column, and in the middle, the data are ranked from smallest to largest. With the data ranked, we find the sum of the ranks for each of the commercials. Commercial 1, the sum of the ranks is 62. For commercial 2, the sum of the ranks is 41. And for commercial 3, the sum of the ranks is 17. Now we're going to need to calculate this H test statistic. First of all, note that the sample size was 5 in each group, so N1, N2, and N3 are all equal to 5. The total sample size of the groups combined is 15, so that's our N. We saw on the last slide that our sum of our ranks for each of the commercials are shown here. And so now if I want to substitute these values into my equation, I can find my H test statistic, and it turns out that it's equal to 10.14. From here, I could use a chi-square distribution since I've got sample sizes of 5 in all of the groups. I could use my chi-square distribution with 2 degrees of freedom, find the area beyond this H test statistic, and use that to get my p-value. But instead, we're going to do that process using R. In R, I would use Kruskal.test. The variable with my responses in it comes next, comma, and then the variable that tells which group my values are coming from. And then it gives me the Kruskal Wallis rank sum test. It gives me my test statistic, 10.14. It tells me the degrees of freedom are 2, and it gives me the p-value. So in reality, this isn't something we generally do by hand. It's something we do by R, and that's how we do it. The last thing I would do is make an appropriate conclusion. Remember that my null hypothesis was the medians are equal in all groups, and my alternative is that not all group medians are equal. The p-value was 0.006, so if I'm testing at the 5% level of significance, we find evidence that the commercial is not equally appealing with all 3 types of music. Now, that alone is not a particularly useful conclusion, so I would want to start to think about, well, where do those differences lie? So my next step would be to start doing pairwise tests to see where the differences lie. Keep in mind that if my conditions aren't met for using a t-distribution, then I should really think about doing those pairwise comparisons with a Mann-Whitney test. And I should also be remembering that I always have to correct for multiple comparisons. So once I start using the Mann-Whitney test with a Bonferroni correction, my power is going to be relatively small. So I probably am going to end up having to use descriptive statistics to make a judgment about where the differences lie, as opposed to really being able to find statistically significant differences in those pairwise comparisons. Okay, thanks. Have a good day.